the wings with LEDs module. Then this is the sensing module with the antenna. This is minus, this is plus, and this is the signal out to the pin 5 of the LM3914. Here, this is the optocoupler, this is the Darlington transistor, collector base emitter is this is the plus, this is the signal out, S out, so this is plus 5 volts, which is going beneath it, the optocoupler. This is a signal from the LEDs, basically a wire, but from the minus of the LEDs, the 9th row, and this is the 9th pin because the 10th pin I fuck it up. I think I burned the LEDs, so I linked the 10th pin here. It wasn't linked, but I just stopped the camera and unlink it to show you how the last row is lit. When I doing this, you see, and it's the same in this part. Where let me put some shadow on it. So I highly suspect, you see the last this one, the last one didn't got affected, and the same on the other side, but the link to the pin 10 is from here, from the middle. I suspect that first and the second are just burned, not entirely, because as you can see, you can see the camera is very stupid. The camera from this device, in reality, it's much more sharper point that is there. This camera is auto blurring something. It's hazing. I don't know, but it's stupid. How is getting the image? But you can get the idea. It's not entirely off, as you can see, and I've actually watched it while it was deteriorating in this in a fraction of a second, of course, very fast, but I kind of catch it with my sight. Not exactly directly, but good enough to see what happened, and I believe they are burned from an over voltage. I was playing like a idiot and probably I connected the 5 volts directly on the LEDs, and as you can see, I have absolutely no resistance on those LEDs. They are directly linked to the IC. I know the IC is having inside him resistors for each pin, but for some reason they are not working for all of this. Still connected to the 9th row because the 10th is damaged. Now what it does, I suppose this is what you wanted to understand. This is the entire thing. As you can see, it's pretty big. This is the latching or switching circuit from here to here. Right now at this moment is drawing 20 milliamps. Watch what is happening right now. Usually is not 100, is 90. This is the off, and this is on for the one relay. This is both relays. Well, 100, 90, both relays, and this is on one relay, and this is off. Both relays are off, and 20 milliamps is drawing probably that LED and some stuff, but it's very low, which is very good. All right, so the latching circuit, this is the plus and the minus, and the middle is the signal, which is somewhere there. Actually, I can show it here. I can bring the schematic here if you want. So it's the same thing. The drawing helped me immensely. I'm very happy I did it, because look what crazy is there, how much crazy, and it's I did it exactly like there. This LED, I leave it here for now, for the moment, just for to see what happens to that terminal, and actually this is the output, the final output here. This terminal is for this relay. So if I'm doing this, that is open, that LED is open. I'm not sure if you can see it right now, and this is switching, and now is off, now is on, and the relay is clamped and in tension right now. But this one is not. This one is only on off every time I'm giving a signal. But this one is staying off or staying on. So it will consume and be under power every time I have the lights on, because here it will be the 220 volts alternative for the light, and yeah, for the light from the ceiling in my room. So basically that's it. I'm the problem is first I have to get very close to it. I have grounded the table. It's here it is. This is actually from a transistor, a broken transistor, with the heatsink, no? And I enlarged a little bit the hole and put a screw in it, and in the table I give what is called, I make a fillet. So yeah, one problem Number one is I have to get very, very, very close to it. I'm not, I think it's power related right now. Is not that interference from the ambient surround EMF, electromagnetic field or something, and that's one problem I have to resolve, and I'm not very sure because this sensing circuit is a odd, very weird. I had a lot of problem with it, and my idea, so you see how close I have to go to get there, very, very close, and the range is super little. The range is from here to here is like I'm pressing a button almost. I don't like it. I want it, here is how I want it. From here to start lit the first until here the last. So a very large range I want to do. This is the idea. This was the idea all the way, all the time. You can see how he's doing everything. I'm happy so far. I made it so far. Now I just made this circuit after I talked with you. Before I talked with you, I used the same actually components, but probably a different resistance for the base of the transistor. You can see it here, a little dot, black dot, which is the same idea, which is and the value is 1 kilo. I used 5 kilo before this one, also same idea, and the delay, as you can see, I'm not sure if you can see, now it's kind of working fine. You see now, when I'm getting the hands off, is like I don't know, 300 milliseconds off, but it was larger. The delay was larger, way more larger, and even with the resistor that is now, because I'm not sure why. I have no idea why. Probably this circuit is interfering because there are two capacitors, this electrolytic and those, which is one actually. Actually, you will like this. These are parallel capacitors. 400 nanofarads. It should have been 1 microfarad there, but with 4, meaning 400 is working fine, optimal, which is awesome. I had a very large, super large 1 microfarad capacitor fixed, and I couldn't use that. It was like a brick, like this. It was probably larger than a little bit larger than the relay. It was, yeah, and those 4 are fine. They're flat on the side, so it's good. So yeah, it seems that is okay now. Thankfully, if I'm adding another transistor, also darlington, also in a darlington way, when I'm doing this, when the first, wait, like this, when I'm here, almost here, the LED, the green LED is opening, is super sensitive to the tiniest modulation in the no in the tiniest variation in the voltage. Very interesting, very interesting, but unusable in my case. And this probably I will have to add it here somehow, or a darlington transistor or something on the output maybe. I'm not sure. I'll have to test this. What is working now, which is not a problem anymore. Sorry to alarm you. It resolved it resolved by itself. Check this out. I did this when I put the ground on the multi socket. I don't know how you call it in America. The white multi socket. When I put the ground, I put also the single LED and the flashing LED. Well, there are two, but in parallel. I count it as one. So two LEDs with two different circuits. But it's fine. It's good. It's nice. And let me show you the other ones here. Brand new, very cheap, very shitty. In interior was very shitty, but it worked. It works. I'm not sure you can see here. There are 3 wires. 1, 2, 3, and that is a long motherfucker that is going to the other point. Yeah. So that's it. I think I had good luck right now at this point. I hope it will not fuck up. And I'll have to enlarge the sensitivity of that component. I had immensely good luck with this right now because it's working, because I can jump to the final component there to enlarge its range. So this is working. It's fine right now at the moment, even if it's that slight delay. It's fine. In the beginning, when I mounted, I'm imagining maybe the components were hot because and they very slowly cooled down, and I was testing them and having very weird results. Who knows? Very weird, but it's working. And yeah, I have to resolve the last LEDs, but that is final problem. This is more important, the sensing wire, because right now it's way too short. I don't like it at all, this short. It must be more range. Alright, that's it. Good night, and thank you very much. Bye bye.